Hi, glorious day, January 18th in Wisconsin. A little warm these days. Back in the same place I left you in the fall. All the garlic beds are nicely composted with manure. Sleeping still. Hopefully the weather doesn't get too warm to sprout them. And all those coals I was munching in, gonna have to pull them. Looks like there might be some edible sprouts up there. But these guys you gotta pull and throw them to the chickens. So you'll leave the disease in your soil, and then it's not so pretty. So I gotta pull them all out. But I'm not here to do that today. I'm here to talk to you from our garden ramblings. I think gravity all the time. Surprise, surprise. I can't get it out of my head. When my mind wanders, it wanders there. So I figure I should keep going on the thought that I've been going on in terms of, we're going to talk about some fundamental principles of chemistry and physics. They're just basic rules that are never broken, and they find them every time they do an experiment. So it's, I forget there's a name for it, but there's two in chemistry: like dissolves like. And then the other one is no reaction ever goes to 100% completion. There is always a small amount of reactants and products reacting back and forth. So that never stops. When you look at the tiniest, like even when you stick like baking soda and vinegar, you explode your volcano for your science project, there's a tiny bit of the reactants, which would be the baking soda and vinegar, switching place with the carbon dioxide, and I forget what the other substance is. Water? I don't remember. I'd have to look. I'd have to write out the equation. Anyway, there's always a small amount of those moving back and forth, moving back and forth, moving back and forth at the tiniest levels that is indistinguishable to the human eye. So that is the primary principle that my theory of gravity, well, not mine, it's the big man's upstairs, it's his theory. I'm just helping you hear it. Understand it, should I say. It's kind of like the elephant in the room. I introduce nothing new except for a possible Earth core explainable through this theory. A hydrogen ion core surrounded by a iron mantle. And that magnetism and the dynamic equilibrium of charges, positive and negative, moving back and forth, since all matter is always in motion, moving back and forth. So kind of like that, no reaction ever goes to 100% completion. Gravity is a constant reaction, a transfer of positive and negative charges moving back and forth, back and forth, back and forth, back and forth. So it's not a new concept. We know it is. And we are operating all the time on charge. Our muscles, it's calcium pumps, that's a charge thing. Our energy, ATP, is the movement of an electron down an electron transport chain. Everything is a movement of electrons, even a rock. Even this brick and this deck are always in motion. Down at the tiny microscopic level in the bonds, they're springing or bouncing or moving. Everything's always in motion. So instead of looking at things in a positive and negative, we're looking at things in motion and still. But what of matter is still? The only thing in matter that's still is a hydrogen ion. It is only a proton. There's no electron whizzing around it. It has a positive charge of 1 because it is one proton. There's not even a neutron in that baby. It's just a proton. A hydrogen ion is just a proton. So if we think of things like in light of positive and negative and stillness and motion, so anything positively charged, if we hypothesize that the core of the earth is made of hydrogen ions, anything bearing a positive charge or stillness, so to speak, would repulse the earth core. Anything that would have a negative charge or is in motion would repulse the earth's core, attract to the earth's core. I'm getting ahead of myself here. So let's look at the repulsion of the earth's core real quick. What kind of things carry in general a positive charge. So like when we see a balance of charges in ionic metals, right? And calcium, lithium, cesium, all these things carry a positive charge. Iron carries positive charge. So let's look at structure. Things that would bring us upright tend to be things of positively charged that provide structural mobility, like our bones, for example, are made up of calcium. Calcium has a positive charge and repulse the Earth's core, therefore allowing us to stand upright and repulse gravity in opposition to gravity. Iron. We use iron to build buildings, for crying out loud. That heavy substance, or at least feels heavy to us, stands up with a positive charge, repulsing the Earth core. So these are just a couple of examples of, positive things. If you look at metals they used to build airplanes, they're all positively charged metals. Lithium, I forget what some of the other, I'm going to look at my periodic table element, look down that first and second column. But those are going to be your metals that they use to make lightweight bikes out of and lightweight airplanes out of. So all these things are a repulsion to the Earth's core. Let's look at negatively charged things for just a moment. So anything negatively charged would move back to the Earth, ideally. Let's just look at something super fundamental like lightning. Lightning, like 99.9% of lightning, something like that, some ridiculously large percentage of lightning. You have to go look at the Handbook of Chemistry and Physics. It tells you in there. Is negatively charged. So it goes from the clouds to the Earth. When we have electricity, like we get electrocuted, that's all electrons, and they want to go into the Earth. Why do they want to go into the Earth? Because they want to be attracted to the positively charged core, the hydrogen and ion core. Okay, so no reaction ever goes to 100% completion. So all the time we've got this fluid motion of positive and negative charges. So that's why I call it a gravitational dynamic equilibrium, because it's a dynamic, meaning it's in motion all the time. It's an equilibrium because it's balanced. So then the other fundamental rule, like dissolves like is another fundamental rule of chemistry that deals with polarity. So if a molecule has a charge, then it's polar. If it doesn't have a charge, it's nonpolar. Oils are nonpolar and they float. They don't have a charge. They're kind of neutral. Polar things like, your water, if you float your oil on your water, the water sinks, it's charged. Okay, we're going to get back to water because water is crucial to our understanding of gravity here. Okay, so now let's move to one other fundamental law of physics, that a sphere in solid form is the lowest energetic form of matter. Well, we see this all over the universe, down from an atom, which is a sphere, all the way to planetary motion. Well, sphere, elliptical, but the motion is elliptical, but the shape of the matter is spherical because it's the lowest energetic form of matter. So you figure any point from the center is equidistant from that point. And since the molecules are moving the slowest in a solid, that's why it's a solid, and moving in water, they're a little faster, liquids, and then moving in gases, they're moving really super fast. So anyway, so a sphere is the lowest energetic form of matter. So we're going to just take a look at why this gravitational principle works in a super big, grandiose, perspective. Like we are on this Earth. Earth. The general shape of the Earth is a sphere. What the Earth wants to do is maintain its sphere. Now, every day we're doing things like, building houses and structures and digging holes and changing the surface of the Earth. We dig wells, we dig for oil, we climb mountains, we do all sorts of crazy ass stuff to change the dynamic of the sphere on Earth, to change the matter composition. We take solid carbon from the Earth and we turn it into a gas. So what happens when this happens? So accordingly to the big man upstairs, what happens is we need to maintain the sphere. So first, the good man is going to start moving the gases. He's going to start moving the weather all around. He's going to start moving the air all around us. And when he moves the air, he can sort of adjust for these little charge imbalances that occur when things are getting moved around. Now, when it gets a little worse, he starts moving water. Torrential rains come down on the earth and flow in ways of the landscape to sort of fill in that sphere, right? To sort of keep it more spherical. Well, when we start having bigger problems and there needs to be bigger adjustments, the big man says, oh, time for a rumble. Let's get those tectonic plates moving and let's rumble. So then we start getting earthquakes and sinkholes and stuff like that. Okay, so these are adjustments to the Earth's mantle to maintain its gravitational dynamic equilibrium. So why, do you ask? Like, how is it that life can exist on this planet? That's been like sort of a fundamental question that we always ask, right? Why does life exist on Earth and nowhere else in the universe? And everyone's, it's water. Water is the key. But why is water the key? Yeah, well, you need to stay hydrated. So we need water. Yep, but why do you need water? Because water, hydration, it's like a circular logic. So let's look at why water is important. So for us to understand water, we need to understand the shape of water. Can I make the shape of water out of anything around here? The shape of water is like kind of like a corner. I don't know. Let me see. We're gonna take a little walk. Anyway, I gotta bring this cart up. Do some chains on, which at that time I have to turn you off. But let's see. So we can make the shape of water. Let's get creative here. I gotta have some like sticks and stuff around here. Of course I've got sticks. The shape of water is crucial to the understanding as to why it is so important to life on Earth. Okay, we're gonna use a couple of these sunflower stalks for the bonds. So water is hydrogen and oxygen, H2O. We've all heard that before. H as in, and then two of them. So we have 2 hydrogen and 1 oxygen. So, and I'll use my pots here. This might make it a little bit more, now, try to make it as, I don't know, symmetrical as possible. Forgive my model here, but this is what water looks like. Oh, these might work real good. 4-packs are going to work real good for this. So I'm going to use the 4-packs for the bonds, because each 4-pack represents 4 electrons. Okay, because it's important to understand the location of the electrons in water. Okay, so this is what oxygen looks like. Or oxygen. I'm being silly. This is what water looks like. Okay, this is your oxygen molecule right here. These are your 4 electrons. See, there's 4 packs, 4 pots. 1, 2, 3, 4. Each one is electron. 1, 2, 3, 4. Not exactly their placement, but where they are. This hydrogen and this hydrogen are in this molecule. Hopefully you can see all that, because I can't see what you can see right now because of the way I've got the phone position. And then you see on the other side of the oxygen, there is 4 electrons over here. So these bonds right here, so these are like boing, 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 boing. They're springing back and forth like that all the time, okay? And over here we got electrons. They might even be springing all the way over there, but they do it simultaneously. So these positive charges are at this end and the negative charges are at this end, okay? So one of the things we have to note about the water molecule is you have what's called, remember I mentioned before, dipole, polar. One end is positive, one end is negative. This is a dipole moment. This, molecule moves in other ways too, but it's not really relevant to what I'm trying to get at with water being a fundamental of Earth. Okay, so basically what you need to know is this side over here has a slightly negative charge. This side over here has a slightly positive charge, because there's a proton in each one of these hydrogen atoms, okay, in this molecule. So water moves. We know how liquids move. It just swarms and moves and swarms and moves and swarms and moves, and it moves smoothly across each other. So water has the fundamental property of being able to rotate very easily. You shift one side, one positive, one negative, and it'll kind of hold like a lattice work within itself, charge-wise. So 70% of humans, me and you and me, 70% of us is water. 70% of the earth is water. So remember when I talked about charges being fundamental for the that's what holds us on, this equilibrium, this movement of charges. So it allows humans to exist on earth, this in our bodies and on the earth. There is the ability for water to rotate and cushion what's going on in the earth, to cushion gravity's movement of charges. So we're 70% cushion and 30% other matter that holds us together. And then, of course, we get into consciousness and spirituality, but that's a whole nother subject that I'm not going to breach. Anyway, this is getting super long. I'm at 15 minutes, and I don't want to put anyone to sleep. So just take that food for thought for now. The earth is maintaining its sphere, and we can adjust to the fluctuations and charges on the earth's surface, repulsion and attractive, stillness and motion, by the rotation of the charge in a water molecule, the physical rotation of the water molecule itself. All right, thanks for listening to Garden Ramblings. I'll see you next time.